Good evening all, this is Satish Kumar. Now let us see the video lecture series on operation of signals. See operation of signals. Before going to see the operation of signals, we can see the standard signals in your previous video lecture series. Now we can see the operation of signals. Different operations are required for different purposes of arbitrary signals. The operations of signals can be time shifting, time delay and time advancing. Time scaling, it can be divided into two types: time compression, time expansion, and then time folding. Right, this the original x of t is shifted by an amount t naught, that is having minus 2 to plus 2 with respect to x of t. X of t is equal to x of t minus t naught, that is signal delayed shift to the right. It can be delayed by the 2 units, therefore we can get it as your t naught minus 2 to t naught plus 2. It can be delayed by the 2 t naught units. Right, this is x of t is equal to x of t plus t naught, signal advanced, shift to the left. Delayed means shift to the right, advancing means shift to the left. Plus indicates advancing, minus indicates delay. In your previous signal, it can be advanced by 2 units, therefore minus t naught plus t2 minus t naught minus 2. The signal is advanced by 2 units, the t naught. This is the time shifting for the x of t for the given function, which can be represented with respect to minus 1 to plus 1. It has an amplitude of 3. That is, signal can be delayed by 1 unit, which can be represented by, it is delayed by 1 unit, that is nothing but 0 to 2. Time advancing means it can be advanced by 1 unit, therefore 0 to minus 2. See, plus indicates advancing, minus indicates delay. The time scaling for the given function x of t. X of at is the time scaled version of x of t. For a greater than 1, period of function x of t reduces and the function speeds up. Graph of the function strings. For a less than 1, the period of x of t increases and the function slows down. Graph of the function expands. Right? The given x of t, we were going to find the y of t is equal to x of 2t. The given function can be represented by x of t. The y of t is equal to x of 2t. Therefore, the signal gets compressed. The period of x of t is 2 and the period of y of t is 1. So, the signal gets compressed. Right? For the another example of time compression and time expansion, w of t is equal to y of 3t, v of t is equal to y of t by 3. For the input function, y of t is amplitude has to 0 to 3. That is, w of t is equal to y of 3t. The signal gets compressed. V of t is equal to y of t by 3 means the signal gets expanded 0 to 9 with respect to amplitude of 2. Next one, another example of time compression and expansion. For the given sum minus 2 to plus 2, it can be represented as x of t with an amplitude of 1. Find y of t is equal to x of 2t, y of t is equal to x of t by 2. Time compression, y of t is equal to x of 2t. Therefore, the input function is minus 2 to plus 2. Therefore, x of minus 2 to plus 2 will be considering it can be by minus 1 to plus 1. The signal gets compressed. That is nothing but y of t is equal to x of 2t. Y of t is equal to x of t by 2 means the signal gets expanded. Y of 2 is equal to x of 1. Y of minus 2 is equal to x of minus 1. Y of minus 4 is equal to x of 2. Y of minus 4 is equal to x of minus 2. See, input function minus 2 to plus 2. The output function will be minus 4 to plus 4. The signal gets expanded. Next one, this is the another representation of time compression and expansion for the given signal x of t with respect to minus 1 to plus 1. X of 2t means the signal gets compressed. X of t by 2 means the signal gets expanded from minus 2 to plus 2. Next one, time folding. Time reversal is also called as time folding. In time reversal, signal is reversed with respect to time. Y of t is equal to x of minus t is obtained for the given function. F of t with respect to t, that is the f of t, f of minus t is the folded signal of x of t. In terms of discrete also, x of n can be given. X of minus n is nothing but your folded signal of x of n. Next one, this is the another representation of signals. Draw the signal u of n is the minus u of n minus 1 is equal to del of n. U of n is nothing but, already we can see the standard signals. U of n is equal to 1 for n greater than or equal to 0. Therefore 0 to 3 up to etc. with an amplitude of 1. U of n minus 1 means it can be shifted by 1 unit. Therefore 1 to 4. See, u of n minus 1 means, that is minus of u of n minus 1 means, that is the folded signal of u of n minus 1. Finally, u of n minus u of n minus 1 means we can get all the signals are cancelled. We can get it as your 1 as the amplitude, which is nothing but del of n. Del of n is equal to 1 for n is equal to 0. Next one, we can see the assessment. List the transformation of independent variable of the signals. It is of time advancing, time delay, and time scaling is of time compression and time expansion, and then time folding. In time shifting, plus indicates advancing, minus indicates delay. Time folding is also called as reversal function, reflection, time reflection function. Time scaling is divided into time compression and expansion. X of t is equal to is the folded signal of x of minus t. If a less than 1, the signal gets expanded. Thank you.